Okay, let's continue with our discussion of domain and range, okay, and formulas. So there's formula. The largest possible set for each domain and range is the set of all real numbers, because all real numbers is the biggest set of numbers anyway. It's infinite, right? It goes from what is the smallest all real number that you can think of? Yeah, what's the biggest all real number that you can think of? So anytime they say the words all real numbers, that's from negative infinity to infinity. That's the interval that means all real numbers. Because math is a very symbolic language, right? I don't want to write out, I have to write out all real numbers. I have to spell all those words, right? No, I don't. I can just write that. That means the same thing, right? And on your web work, you'll write, you can't put that symbol in. So you write, this means the same thing as negative infinity to positive infinity. That's what you write on the web work, okay? And you always put parentheses around infinity. So far, there are two primary possible circumstances that restrict the domain. When a number causes either of the following to happen, it has to be excluded from the domain. And by the way, we saw this when we were talking about the rational function, and we put 3 in the denominator, and it gave us undefined, okay? So if you're going to be dividing by 0, and this would happen in a rational function, or if you're going to take the square root of a negative number, that actually happens in a radical function. Okay, a rational function is like a fraction. A radical function is a square root. So they take the square root of a negative number. So for example, if you want to find the domain of this function, we're saying that what number would cause there to be a 0 in the denominator? What number can you think of would give you 0 in the denominator? This number is going to be bad for the function. It's not going to work. You can't use it. It's off limits. So what number will give us a 0? If you don't know, you could always set x minus 3 equal to 0 and solve, right? And I think you already know that it would be x equals 3. So the domain then, if we set the function equal to 0, or the denominator, sorry, if we set the denominator equal to 0 and we solve, this is going to tell us the number that we can't have. Okay, and I left all this space because I meant to do this down here. So the domain is going to be x such that it's all real numbers except for x cannot equal 3. In fact, the way I usually write this is x such that x cannot equal 3. That pretty much is saying the exact same thing, because it's saying you can use whatever x values you want, but just don't use 3. Does everybody understand why we can't use 3? Any questions on that? Okay. Here, this is the same exact thing. This is the interval, saying you can go from negative infinity to 3, but don't include it, union 3 to infinity. Okay? So you're starting at negative infinity, you're going to 3, don't include it, union 3 to infinity. It's almost easier to write it in this notation, right? Because that's kind of a lot. Now here, this is what we call a radical function. So this one right here, we're going to get more into this. This is rational. This is going to be in chapter 12. We're going to look at rational. This is a rational type of function. This one is a radical. Does anybody have any thoughts as to why we might call this a radical function? Exactly. And the square root is called a radical. Yeah. So rad, because it's radical. Okay, note that if you substitute the value of x, the only thing that might go wrong would be if you ended up with a number that was negative, right? If that produces a negative. Therefore, the good values of x would be when everything underneath the radical, x minus 9, has to be greater than or equal to 0. So how could we solve that inequality for x? What numbers are going to make under the radical be bigger than 0? Any thoughts? 10 would be good. And actually, if we go plus 9, x should be greater than or equal to 9. That's our domain. So the domain is 9 to infinity, and you just included the number 10. That would be included. 9, 9.5. But if I put anything less than 9 into that radical, I'm going to end up with a negative, and that's not a real number. We are going to look at the graphs. It's going to be really cool because when you use your Desmos to look at the graphs, you'll understand the domain a little bit better. Okay, and then another way of writing this is, actually this should be x such that, there's a little typo, x is greater than or equal to 9. That one's incorrect. I must have made a typo. Any questions about the domain and the range of those functions? So really, there's just those two special cases that we're talking about, rational and radical. If it's a linear function, if it's a quadratic function, our domain, we don't have a problem plugging in x values. We could do that all day, every day, for the rest of our lives and get an infinite number of y values. So those ones we don't care about restricting the domain. We would say that the domain of a linear or quadratic is all real numbers, right? A line or a parabola. Okay, any last questions on that?